Welcome to Learn Extra Teacher Talk, colleagues. It's good to be with you. Today our focus is on mathematics, the teaching of mathematics, and how we can discuss different issues that relate to the teaching of mathematics that will impact learning and teaching within the classroom. So let's have a look at what Learn Extra is offering to learners. And one of the things that we need to understand is that Learn Extra runs during the week as well as on the weekend. Now, during the week, today we are focusing on mathematics, and the schedule should be familiar to you by now. We have a grade 10 hour between 4 and 5 o'clock, a grade 11 hour from 5 o'clock, and at 6 o'clock it's the turn of the grade 12s. But over the weekend there are set slots for mathematics, and mathematics takes place at the beginning of the day. So on Saturday at 9 o'clock, let's have a look at that. From 9 o'clock until 10:30 we have grade 12 mathematics. Saturday is a grade 12 day. We repeat the evening slot from today's broadcast between 3 and 4 in the afternoon, and then on Sunday we have a pickup for the grade 11s this week. Alternate grade 10 and 11. So last week was grade 10. This week we're dealing with grade 11s. And so mathematics will take place at the same time slot from 9 until 10:30, and as well from 3 until 4. Now, it's important that learners are encouraged to participate. We really do value their contributions, and they've been doing magnificently. We're up to almost 10,000 learners having contributed in some way in the last couple of months, and we'd like to push it closer and closer to the 10,000 and beyond. The more learners we've got, the more impact we're making. And so we'd encourage you to get your learners to get involved. How can they do that? Have a look. Here are the contact details. They can phone us during the learner shows on 086 1058 262. If they don't get answered straight away, they can leave a message, particularly with an email address, and we'll be able to reply to them. If not, just a voice message and we'll phone them back. They can also email us, particularly where they've got issues or problems that they've tried themselves. This isn't a homework service, but if they've tried a problem, helpdesk@learnextra.co.za, and we will do our best to get back to them within a short period of time so that they can get the benefit of guidance on how to solve certain problems. Now, the most interactive platform is on Facebook. So Facebook, the website there, go to facebook.com and Learn Extra with an X. That's for the learners. And then our Facebook page for teachers and interaction on teachers is Learn Extra Teacher Talk. Let's go and have a look at that particular Facebook page so that you can have see what's going on there. And you'll see that there is an ongoing conversation telling you about what we're doing today. In today's session, we are going to discuss approaches to teaching the topic of functions. And this is across the board, grade 10 through to grade 12. It's a fundamental building block, and it's something that many teachers are doing right at the moment. Maybe you've started teaching functions and you're concerned that your learners haven't grasped the full impact of the concepts that are required. That reflection is a very good process, and we need to go through that to make sure that the approach that we're choosing for our learners is one that is going to fit with their particular needs. Okay, so right after this we're going to go to a short break, and then we'll get into aspects around teaching of functions. We'll see you in a minute. Welcome back, colleagues. This is Learn Extra Teacher Talk. My name is John. Our focus today is on the teaching of mathematics. Now, I'm sure you'll agree that many of us have different preferences for teaching different sections. One of my favorite sections is the teaching of functions. I want to show you that there are a number of resources that can assist you in the teaching of functions. Last week we went through some of the mindset resources. Just to remind you, you can download and you can get hold of lots of mindset resources by going to our website. So let's just have a quick look at that so that you can have a look and see the mindset homepage. You select mathematics, And if you do push on that button there for mathematics, you'll be able to get to the different learning areas. And if we go to functions in algebra, you'll see that there are an extended number of different topics for both grade 10, 11 and 12. We're not going to go into the detail of those today, but just to mention that they're there. The other thing that you need to be aware of for your learners, as well as for your classroom practice, is that we have a mindset channel on YouTube. Let's just go and have a quick look at that. Now, if you just go to YouTube and you then type in, after youtube.com, you type in /mindset learn, you'll get a whole list of different video resources. They range in their subjects, and there are numerous videos that are available, both ones that we've recorded live as well as the ones that we've pre-recorded. If you want to focus in your search a little bit, there is a little search button that you can choose that's in this section of the room, and you can choose different ideas from teacher talk, type in the value and get the ones that you're particularly wanting. So you could choose mathematics, functions, and maybe you'll get a couple of videos that will pop up that will assist you in giving links to your learners for revision purposes, or that will be able to give you a tool that you can start a lesson and introduce a lesson on functions. Now, we're talking very generally here because functions builds up, as we mentioned last week, from grade 10 through to grade 11 and on to grade 12. And it's critical that that building continues stage by stage. We don't want to try and overload learners. We want to develop the concepts and build them so that they are very familiar with what's going on in functions by the time they get to grade 12, so that they can learn to apply this knowledge, particularly in the topic of calculus. So what do we need to do to make sure that our learners' understanding of functions is as good as it can be? Well, there's lots of research on the teaching of functions, and I would encourage you to go and have a look, use a web browser and search for different research papers on functions. If you go to Google and you use Google Scholar, you'll find that there are a range of options that people have been researching, different ways of teaching, and they have published these in academic journals that sometimes are a little bit hard to read, but they give you good ideas for the teaching of functions. And I would really encourage you to go and have a look at those. Well, what can we take out of the research? What can we take out of experience talking to teachers? Well, there are obviously a number of ways of approaching functions, but functions can be very abstract, and yet it doesn't have to be. It can be very practical. And I would really encourage you to try and contextualize the teaching of functions so that learners don't just, particularly where they've been in grade 10, where they've had lots of algebra thrown at them, here is an opportunity to make relevant links to real-world situations and real-world applications. And so there are many all around us, and we'll discuss a few of those. But like any new topic, and particularly this one in mathematics, the terminology is important. And I mentioned last week that when we are dealing with functions, unfamiliar terms like domain, which links very closely to the idea of an input, and range, which links to the output or the set of output values, that learners need to be familiar with this, and they need to be able to understand that there is this linking between variables. The idea of a variable is also important, that they can recognize that a variable is a set of numbers, that we can change those numbers, and as we change those numbers, if we change the input, we're going to change the output in a defined way. So there is a rule that describes the relationship between the input set and the output set. And so some people have even developed an analogy that they call a function machine. The way that I like to think of it is, I remember in the old days, my mother doing lots of baking, And one of the things that she used to do is she used to make mincemeat, not from beef, but from fruit and all that for the Christmas mince pies. And so she would make mincemeat out of nuts and raisins and all sorts of goodies, dates, and put them all into this mincing machine. And you would have a handle on it. It was all very manual at that stage. So you'd have your input that would go in over there. And at the end of the process, you would get an output over here. You'd have to turn the handle a couple of times, and then you'd be able to collect this bowl of minced fruit that you would then be able to put into a tart or a mince pie that we would enjoy. The idea of a function being very similar to that is one that perhaps one could mention to learners. And I suppose instead of talking about mincemeat today, we would talk about making sausages or making boerewors, where different varieties of meat are put into a mixer and blended together, and out comes the sausage at the end that contains a variety of different things. The important thing is the process. In this process, we're doing the same thing, the same operation, every time we turn the handle. And that's the analogy, and that's the concept that we need to get very clear in our heads. We need to get our learners to be very comfortable with what a function does. Now, typically in mathematics, we don't just want to put all of this dialogue that we've been speaking about into a long paragraph. We want to be succinct. We want to be elegant in being able to summarize that information. And so one way of summarizing that is to introduce a notation that is known as function notation. And instead of there are different function notations. One of them is simply to write an equation where we have two variables. So for example, we could say y equals 2x plus 2. What is this telling us to do? If we recognize, going back to the idea over here, that the x values, all the x values are input values and all the y values are output values, they are variables. They are numbers that we're doing something to. So what is the rule? What is the process that we're saying? We're saying there's a relationship between an x value and a y value. And what is that rule? It says for every x value, what you must do to it is you must take the x value, and the first thing you're going to do is you're going to multiply that value by 2. And then having multiplied it by 2, you're going to then add 2. This will generate a whole number of values. So it doesn't confine us in terms of what the input values are, but dependent on the input values, we get a whole range, a whole set of output values. That set of output values makes up the range. And so what we need to recognize is that for every input, there is a unique, there's only one output. That's if it is a function. We can have relationships with a whole lot of other things mathematically, but for functions, the relationship means that if an x is a certain value, be it 2 or 1 or minus 2, for every one of those input, there is only one output. There is only one y value. And so that's quite important for learners to understand, that it's this sort of mapping. Now, what I'm saying here we'll discuss a little bit more when we deal with the idea of mapping. But in simple terms, we can have a more elegant notation that is used from grade 10 all the way through to grade 12. We give functions names. So this rule, we might give a symbol and call it f or g or h. And in that way, we would be able to write down the notation more appropriately. We'd say f of x in that form, f brackets x, close the brackets, says f of x is equal to 2x plus 2. That's saying we're taking the x values, and what we're doing is we're applying the rule. And the rule is multiply the F rule. The F rule says multiply by 2 and then add 2. I hope you can see that this mechanism, this structure, this way of explaining what a function is, can be quite useful. Now, the other way of doing it, or another way of doing it, can be referred to as mapping. We can tabulate a whole lot of inputs. So we can say, here are our inputs, and here are our outputs. And in this case, we're going to just take a few. We're going to take -2, 0, 2, and let's take 4 as well. And if we do the rule, now the rule says this, that what you must do is 2x plus 2. So whatever goes in here, you're going to have an output. And the output is going to follow that rule. And so in this case, 2 multiplied by 2, -2 multiplied by 2 is going to give you -4 plus 2 is going to give you -2. If we carry on and we say 0 multiplied by 2 plus 2 is going to give you 2. And then if we do 2, we'll put in 2. Multiply by 2 gives us 4 plus 2 gives us 6. And if we did 4, we'd get 8 plus 2, which gives us 10. So what you can see is that there is a direct relationship, a mapping between the input values and the output values. For every input, there is one output. And what in this case we would recognize is that the inputs and outputs are unique. The outputs are not repeated. They are unique. And that's what makes this a particular type of function, namely a linear function. So what we recognize, it is an example of a one-to-one mapping. There are other types of mapping where we could have one to many or many to one. The example of many to one is a function, whereas one to many is not a function. The output must be unique. And so we need to get our learners very familiar with this type of language, this type of terminology. And so we could have tables, and we could have rules, and we could have ideas around that, but probably the most common way of expressing functions is by graphing. And so at grade 10 level, we would encourage learners to become familiar with the x values represented on the Cartesian plane as the horizontal axis, and the output values or y values represented on the vertical plane. We can then take an x value and we say, what's the y value that's corresponding to that? And we'd find, oh, there's only one y value, one output that's corresponding to that, and it's that point. And then we'd take another input value and take an input value that's somewhere over here, and we'd find, oh, there's the output value. Let me change the color just to give you the output value. When I put the dot there, what I'm really saying, and this is something important, so we need to take a note of it. We're mapping in an ordered pair. We're giving an x value and a y value, and learners don't always see the graphical importance. So I'm going to illustrate that practically by putting in some values, even though this was originally intended to be a sketch graph. So let me do it over here. We say if this x value here was 2, and that was 2 on the on the x side, then let's make that value there 1. So the x value was 2, the coordinate is 2, and the y value is 1. So we have a relationship 2, 1. What did we do to the x value to make it 1, to make the output 1? We perhaps multiplied by half. And so in the same way, we could get to an x value here as -2, and we would say, well, let's predict what the y value would be, and we wouldn't be wrong in predicting -0.5. Now, -1 at least. I hope you can see that this is the y value on the vertical axis. So the y value sits here, but the mapping of the two, the x and the y, is a point over there. And so we would say -2 being the input value and -1 being the output value. Now, we could apply that rule to a number of points all the way along the x-axis. Take as many as we like. And what we'd find is these points all marry up until we get a set of them that follow the rule. And there would be just as many output values as input values. Those output values can then, point by point, even not just dealing with integers. If we were just dealing with integers, we'd have to just plot the integer values. But if we did the numbers between, and we got all the real numbers, what we would find is we get a straight line that would then pass through those points and at the same time pass through the origin. So we'd have something that looks something like that. I haven't drawn it very accurately. But there is the rule that we've done, a second rule that we've described, where we said y is equal to 1/2 times x. So whatever the x value is, we're multiplying it by 1/2. And we've constructed a picture, a graphic representation. Now, some learners will respond really well to the graphic, and others will struggle. They'll prefer the algebraic. They'll prefer the rule written in a form like that. What we need to do is make sure that our learners can interact between the graphical, the representation, and use as many different forms as we can. Right, now one of the ways of representing these linear one-to-one graphs where they are a straight line, is we begin to recognize these straight lines form many families and they have different properties. I would like to take a look at some of these properties of the straight line and move on as well to talk about other functions. But first of all, let's go to a short break, and after that we'll pick up and have a look at some software that you can use to make sure that your learners have got it very clear how to graph linear functions and to apply the same thinking to quadratic, to exponential, to hyperbolic, and even to trigonometrical ratios, trigonometrical functions. The important thing here is that they've got the basic concept. They understand what's going on. Right, let's go to a break. We'll be back straight after this. Colleagues, welcome back. This is Learn Extra Teacher Talk, and our focus today is on mathematics, the teaching of mathematics as it's relevant to grade 10, 11 and 12 learners and teachers. Now, there are a number of things that we've been saying about term 2 topics. One of the important ones that is covered for both grade 10, 11 and 12 is the fundamental understanding of functions. And so I just want to recap and revise some ideas for teaching functions, because if learners miss out in grade 10, they're really going to struggle with grade 11 and they're going to be lost in grade 12, and we don't want that to happen. There are some fundamental points that research tells us that we need to get learners familiar with terminology so they can translate between mathematics and English, and that they don't develop a language block. They need to be able to identify the key words. It's very important. So I would encourage you, when you're talking to learners and in your classroom, get them to talk some mathematics. Get them to talk through the processes. That is critical part of learning and learning mathematics. One of the ways of encouraging that sort of mathematical discussion is getting learners to explain to each other in pairs or even in smaller groups what they understand by different meanings and different words. So you can give them group work, little checklists to get them to see if they can illustrate and explain very clearly what a function is and to give examples of functions. This will encourage encourage them to make sure that they're checking their understanding as they're listening to other learners who are telling them what they're thinking, so that they can be exact in their their expression. They can be exact in their descriptions. Very important that that is encouraged. So I've given you some stress in terms of the terminology, also in terms of notation. We've talked about mapping a little bit. We've talked a little bit about graphing. And so what we recognize is that graphing is one of the ways that is most often dealt with. These graphs of functions, we need to recognize, are linked to equations. And so there's an important link. Learners are familiar with equations where there is a solution for one number. But a function strictly is a mapping. A function uses an equation with many solutions. And that's the key difference. Learners understand that. They will recognize the algebra that they've done in terms of equations is really very easy to link to functions. Because what we're doing, we're not just using one x value, we're using multiple ranges of them, whole sets of them. We could say only the numbers bigger than 0, or all the real numbers, or only the integers. All of those are valid mappings. All of those are valid functions if they follow a rule that is of a particular form. Now, what I mentioned before the break was that we recognize that certain relationships, certain mappings, certain rules are generic. They have a particular look and feel to them. So if it follows a certain pattern, there is a corresponding graphical output. So we started by looking at a simple rule, which was just multiply and add. Now that little rule always turns out, multiply and add or multiply and subtract, always turns out to have a picture of a straight line. Now, that's quite incredible that it should be as simple as that. But we can do many point-by-point plots, and you'll find that every one of them that follow that rule, multiply the input value by a number, and then add or subtract another number, whether that number be whatever it is, it will always give you the representation of a straight line. All straight lines also follow that rule. So we need to recognize that forwards and backwards relationship, although we do need to discuss one or two exceptions. Now, of the straight lines, we call them linear functions. They have a general look of being a straight line. And because they're a straight line, we need to cover certain important concepts. When we deal with straight line graphs, the first concept that probably stands out is the concept of gradient. Now, if we write down the equation of a straight line, either in function notation or in just an equation form, what we'll have is this. We'll say it's y is equal to ax plus q, where the a value represents the number that you're multiplying the input value by, and q represents the second number that you're going to add to it. This, you will all be aware, is the gradient. And this is going to be the y-intercept. Now, I've just mentioned that very briefly, but learners need some help in understanding this term gradient and understanding the idea of an intercept. So let me help by just unpacking something about gradient and summarizing some trends in gradient. Last week we looked at a whiteboard application which didn't appear to be too successful on television, but they are available on the Mindset website, and I encourage you to use them. Get learners to try different values of A. Get learners to try different values of Q. In the old days we didn't use A and Q, and you might be a little confused by that. We often used to say y is equal to mx plus c. Now, in the same way, gradient and intercept. Those are exactly the same. Textbooks, different authors use those interchangeably, and our learners need to be aware of that. But what is gradient and how can we demonstrate gradient really well for learners? Now remember, these are grade 10 learners. Many of them still need some concrete identification. They need to be able to identify with things in a concrete way. Now here's a suggestion that I've tried in class, and I think it does work fairly well. Now what I've done is I've represented the floor as that green line, and I've taken a piece of string that is of different length, and I've used a ruler to take that piece of string. I'm just going to draw it up like that for the moment. And I say to the learners, how can we describe how steep that is? If I want to put that piece of string in that position every time for the next week, I want to put it tied up so it always makes that particular angle. How am I going to do it? And it's not very long when learners say, well, look, what you could do is, instead of just measuring that angle, which we could do using a protractor, and that's a good thing if they suggest that, because that's the link to trigonometry as an example. But what you might get them to do is to say, well, look, if we measure the horizontal distance, measure that distance, and we can say that distance is 2 meters. And then let's measure this distance. We know we've got an isosceles triangle that's got a right angle in it. One is 45 degrees. Then that must be 2 meters. So there's a ratio between the horizontal and the vertical. In this case, it was an angle of 45. So the horizontal is the same as the vertical. We just have a ratio of 1:1. 2 meters to 2 meters, or 1 meter to 1 meter, or half a meter to half a meter. That incline is very specifically described. We could then say to our learners, well, look, instead of using that angle, let's use a different one. And I'm going to just move down the page and say, instead of using that one, let's draw a different slope. Have the floor in, still the same, but now, instead of using that one, I'm going to use this. And they begin to see that there's a different angle that's been formed. And the slope is pointing in the opposite direction. And so what we've got to do is we've got to get them very clear. If you do this in your classroom with string at a fixed point, that's the 0 point. So we say anything to the left is negative, and we can still measure the vertical. We recognize that that is still a vertical height, and that might just be 0,5, and this distance, this horizontal distance here, might be as much as minus, because it's to the left, have that sign convention, -3. And so we begin to understand that when it leans to the left and slopes in that direction, then it's going to have a negative slope. The idea of negative slope or negative gradient is very important. Okay, whereas this one, which slopes upward, is a positive. From the bottom, leaning upwards, it's a positive gradient, and we can identify that. If you use a piece of string and you slope it above the ground, then they can see the idea of slope. Now, another way is to use some software. And I think I might have shown this to you before, but there's some free downloadable software called Geogebra. And I want to just run through this very quickly so that you can get the sense of what is possible. Under linear functions, I have drawn here a particular function, namely the function y equals x. The rule is wherever you've got an x value, make the y value the same. And in that case, we've got the graph that I've indicated over here. But if I change the rule, and I make the rule y equals 2x, I want you to see that the gradient has increased. The slope has got steeper. It's not as easy to walk up the green line. It's harder to walk up the blue line. However, if I change it and make it a half x, you'll see the pink line is flatter. It's closer to being horizontal. These ideas of gradient are extremely important so learners get an intuitive idea and that they can see the mapping and the equation. They can begin to understand the parameter for gradient is the coefficient of x, is the number in front of the x. And so they begin to recognize that when we make a linear function, that this value here determines the steepness. The value of a determines the steepness. And if it's bigger than 1, it's going to be steeper than 45. If it's less than 1, it's going to be less than 45. Where it's 1, what we're saying is the x value and the y value are the same. That's why the ratio is 1. Just a further aside, just very quickly over here, when we're dealing with graphs, and it's an interesting phenomena, when we're dealing with graphs that pass through the origin, like the ones that I've just shown you, something like that, then what we'll notice, if we tabulate the x and y values, put them into a table, so I'm going to do that right now and say 0, and just take this one as 0, take this one as 1, and take that as 2, take that as 2, and take that as 4, take this as 3, and take that as 6. In this case, the rule is f of x equals 2x. Whatever we've done to the x value, we'll multiply whatever the x value is, we've multiplied it by 2 to get the y value. And we've drawn the line here, starting at the origin. Now, when it does that sort of thing, what I need you to recognize, and this is important because mathematics, knowledge of mathematics links to other areas of life science, geography, physical science. And this particular example is important to recognize that the relationship between the x and the y value can be represented in words. And what we can say is that because what you're doing to the one input, you multiplying, if you multiply 1 by 2, then you'll notice that the same thing happens over here. So if we multiply from 1 multiplied by 2, we're getting 2. 1 multiplied by 2, we take 2, and what have we done? We've multiplied it by 2. That's the rule. Everything was multiplied by 2. And so there is a rule here. As the one increases, the other is increasing. We multiplied this by 3, we've multiplied the output by 3. Recognize that there's always a constant relationship between the inputs and the outputs. That if we take the y value and divide by the x value, we get the number 2. That's the gradient. That's important. So please make sure that you've got it. In terms of sciences, the sciences and geography, we recognize this sort of relationship when it passes through the origin and forms a straight line is known as something that is directly proportional. So very important to have learners recognize the relationship that is described in a linear function is often directly proportional. But if there's a y-intercept, then it's not directly proportional. Let's just have a look at one or two further functions that we've got on this board over here. I'm going to take the line y equals x, and I want to just do the negative just for a minute so that you can see the negative is in the opposite direction, the opposite slope, and in the same way, steep when it's -4, but not so steep when it's -0.5. So you can see how the gradient affects, how the parameter in front of the x value affects the slope of the graph. Now, let's have a look at one more. And what I'm going to do here is I'm just going to take those ones off for a minute and put that one on and put this one on. And I've got one on that shouldn't be there. Right, what do we notice about these three lines? This one, the green one, passes through the origin. The blue one passes through the point 0 plus 2, and the red one passes through the point 0, minus 2. But notice the lines are all parallel. And the reason for that is if we look on the graph, we'll see they've all got a coefficient of 1. If we go to the line here, those graphs were represented by the following functions: y equals x plus 2, and the last one was y equals x minus 2. So it becomes apparent as we plot, particularly you could get your learners to plot, and it's not a bad idea for them to follow the exercise, draw up tables and plot. But using the software really helps us to see that the gradient is parallel and what the effect of the Q value or the C value is to shift the graph up and down. It determines where it's going to cut the y-intercept. And so it's important for learners to recognize, to write this completely, we should really say y equals x plus 0, because it's cutting at the point 0, 0. Whereas this, on the axis, the blue line cuts at the point 0, plus 2. So 0 plus 2 was the blue line, and that was the y-intercept, where x is 0. And where x is 0, on this point, it's going to be 0 minus 2. Now learners battle with that, distinguishing between the x-intercept and the y-intercept. Let's just have a look at the graph once again, and what you'll notice here is that they have different y-intercepts. The difference in the y-intercept is in the blue line, it cuts at minus 2, and at the red line, it cuts at positive 2. The green line cuts at 0. So what we need to do is to make sure learners get the difference between the x-intercept and the y-intercept. Those were all my y-intercepts. What I need to do is to recognize that if I've got x-intercepts, that's where these were y-intercepts. These were y-intercepts. But what we want to do is we want to get to x-intercepts. And the x-intercepts is where x is going to be 0, where the x value is 0. And in that case, we're going to have, where the y value is 0, not the x value. This gives us where x equals 0, y-intercept. What we're talking about, x-intercept, needs to be where y is 0. So when is it on the horizontal line? When does it cut the horizontal line? That's why learners find it a little confusing. So in each of those graphs, make sure that you recognize the difference between x and y intercepts. So in our case, we had 2, 0, we had 0, 0, and we had minus 2, 0. Those were all the x-intercepts, where y is 0. Y was 0, y is 0. Where you'll notice here in these ones, x is 0. Now, I did want to show you some other functions other than the straight line, but the principle applies. Use as many ideas so that you can get the common features of the graphs. And it's particularly important that learners understand this idea of x-intercept and y-intercept, because they're going to carry that through wherever they're dealing with graphs. I would make sure that you spend a little bit of extra time on this function or this concept, even if it's just dealing with straight lines. Make sure that they also understand that when they come to the quadratic function, with the quadratic function f of x is equal to, you can write it in two ways, a x plus or minus plus p all squared plus q, and that could be minus q as well, or the more traditional way of writing it, f of x is equal to ax squared plus bx plus c. Now, in grade 10, it would appear from the CAPS document that the second notation is not required, but for grade 11, it's critical that learners understand that notation because they're going to use it when they use the quadratic formula to find the roots of the equation. Now, just very briefly and very quickly, let's just go through the key points that we need to just mention. And the first one that I want to just allude to is, what does the A do? A determines the steepness of the graph. So we recognize when A is greater than 0, then we're going to have a minimum value as the turning point, a minimum turning point. But when we've got A as negative, less than 0, we're going to have a maximum turning point. Now, these are all important terms, and they're related to the quadratic function. It's really important that once learners have done the plot by plot, they summarize these ideas so that they've got a clear understanding of exactly what's happening. Now, we've run out of time in terms of the other functions, so I really hope that you've enjoyed being with me today, and make sure that you can take a look at the other functions, the exponential as well as the trigonometrical functions, so that your learners have got a well-rounded idea of the teaching of functions. From me, John, it's been great being with you. Bye-bye for now.